Sinusoidal functions are circular functions, which means they can model motions that repeat in cycles. But how does a Ferris wheel create a sine graph? As the wheel rotates, the passenger's height rises and falls in a smooth repeating pattern, and that pattern becomes a sinusoidal function. High tide, low tide, and then the cycle repeats again. Nature itself follows patterns, and mathematics helps us model them. Using sinusoidal functions, we can predict how tides rise and fall over time using amplitude, period, and midline. So this is the extract taken from the syllabus document. Modeling with functions shows sinusoidal models, both for SL and HL. So you can see the only difference with the SL students and HL students is that SL students will only be working with the degree angles, and HL students will be working with degrees as well as radian measures as well. And another thing which is HL only is the phase shift. So I'll be talking about each of these terms. What does these A, B, C, and D means? All right, so now let's take a look at what does each of these A, B, C, and D does to the graph of sine and cos, these sinusoidal functions, dynamically. So I've set a sine function with all these A, B, C, and D's, and I've set my domain from negative 360 to 360. So this is part of the functions unit. So you know what's the domain? It's the horizontal stretch of the function, right? So you can see that A is set to 1 right now, and that is the standard height of the sine wave. If the amplitude is 1, that is like the standard. So if you dive deeper into the course, you'll come across a unit circle, which has a radius 1. Okay, so what happens if I change it to 2? If I change it to 3 or maybe 4? So if I play it, you'll see like why they can be used to model tides and circular motions. You see what's happening? So A stands for the vertical stretch and compression, and we call it amplitude in the wave language. Okay, now let's begin with B. So B is known as the frequency factor. It changes the period of the graph. So right now it's 1. If I make it double, its frequency is doubled. If I make it 3, its frequency is trebled. And you can see like if I half it, or maybe if I 1/3 it, its frequency will be slower. So wave will take longer to complete one oscillation. So I know it's a bit deeper, but you can rewind and check again. And when you get good with it, you can come back and listen to this again. Like this is like a very crucial part. Like what does B does? It changes the frequency. So hence it changes the period as well. There's a formula given uh, in the syllabus document, and it says 360 divide B. Or you can say 2 pi divide B for the HL students. So this is the period or the new period, the changed period. So for example, if I have sine 2x, so what will be the period? 2x equals to 360, and x is going to be 180. So you see, when let me just show you, if I make it double, its period is now 180. It's completing one oscillation now in this scenario in 180. So you get the idea. It shrinks the period. The bigger the value of B, your wave will have a higher frequency. And similarly, the other way around, if it's a smaller value for B, it will be a bigger frequency, so a longer time to complete the oscillation. So I know these are a bit difficult at first, but very crucial to understand the sinusoidal functions. Okay, now the C part. C is HL only. So I'm going to explain this, like what happens if I change C. Okay, let me just make it B1, right? So this, I've set the step size to just 60. I'm just going to show you, like if I change it, my graph is going to translate horizontally, like it's moving left and right horizontally. So if I play it, just take a look at it, like what's going on. So this is a horizontal movement, right? So keep in mind. So another important idea is right now you can see it's written just plus b. What happens if I change it to a minus b? So if I have, let me just explain it. If you have sine of x minus 30, or for the HL students, this is a pi over 6 in radians, right? So you can see that the graph, strange, it's a negative, but goes 30 degrees to the right. Okay, so keep that in mind. And similarly, if it's a plus, it will go to the left. So keep that in mind as well. So this is known as the phase shift or the horizontal translation. Okay, finally, what does D do? If I make D 1, look at this. I'm going to put a line y equals to 1. So you can see that the principal axis or the midline is no longer the x-axis, but it's d equals to 1, like a y equals to 1, a horizontal line. If I change it to, let's say, 3, or maybe something else, let me just change it like, okay, let's just play it. So I've set it. You can see like it's moving the wave up and down, right? So, okay, so it's too much to remember. Let me just repeat it. What does A do? It stretches or compresses the wave vertically. What does B do? It stretches or compresses the wave horizontally. What does C do? It translates horizontally. What does D do? It translates vertically. So these are the key ideas, guys. Take a cup of tea and listen to this again. And then I'll be solving some actual exam questions so you can apply these ideas in the scenarios given in the exam. Okay, so we're going to solve some actual exam questions. This one is from November 2025, SL paper 2, time zone 3. A particular island is only accessible by roads at time when the water level is low enough, otherwise the road is under water. Read the question carefully because often in the exam questions, they ask you to interpret in terms of the context of the question. The height of the water above the road, h meters, can be modeled by this function. You can see it's a sinusoidal function with each time measured in hours from 12 midnight on Tuesday. The first maximum high tide is at 3.36 with a height of 1.26 meter. So this means that I've got a coordinate 3 hour 36 minutes and the max height is 1.26. So I'm just writing it as a coordinate. Sometime if you don't want to write it as a coordinate, you can just write it like the x value over here and the y value like this is 1.26. I've got the max of this wave. And the lowest point is also given. And the first minimum low tide occurs at 10:48 with a height of minus 0.26. So this is 10:48 and a minus 0.26. So now we'll see what the question asks you. Let's look at the parts. Part A. Find the value of A given that A is positive. To find A, you can note down a rule. Subtract max minus min, subtract the minimum value from the maximum value, and half it. So I'm boxing this so you can note this down. So if I have the maximum value, which is in this case 1.26, subtract the lowest value, which is a negative 0.26, and half it. And this will straight away give you the amplitude. So 1.26, add 0.26 since negative and negative is positive, and divided by 2. And I'm getting A equals to a 0.76. That is my answer for part A. Part B. To find B, which is the midline in this case, which is D, you can note down this rule. Midline is max and minimum. Add them and divide by 2. So it's like the average of the maximum and the minimum value. So I'm going to box this as well. So let's take the max value, which is a 1.26, and you can add the lowest value, which is a negative 0.26, and you can have that. So let's go find this out. So 1.26 and subtract the 0.26 and divide it by 2. So D is going to be a 0.5. There we go. Okay. Another way of finding uh, the amplitude is once you have your midline, which is in this case a 0.5, then you can simply find the difference of these two, and that is going to be exactly 1.26 minus a zero point 0.5 is going to be 0.75, which is the amplitude of the wave. How high and low above the midline the wave travels, right? Okay, part C. Find the period of the function in hours. So in order to find the period, just observe this wave. We have the half period somehow given because we know the times. If you find this difference in the times and then double it, that is going to be one complete oscillation. Now listen to this carefully. So to answer part C, just take a look at this. This time is a 10:48 and that is a 3:36. Let's subtract them. It's going to be 7 hours and 12 minutes, right? Let's write it as a complete hour, and that's going to be my half period. So how do you write it? Convert 12 minutes to hours. 12 divide 60, that's a 0.2, and add a 7. So this is going to be a 7.2. So I'm writing it, this is the half period, okay? So when you double it, you will get the full period, which is going to be 14.4. So if you have the answer stored, you can just double it, and that's going to be your period, right? So if you find anything difficult, you can always rewind and check again, like how I'm getting my period, amplitude, midline. Okay, part D, find the equation of the model. Once we have all of our A, B's and D I can write, but right now I do not have the value of B. Listen to this carefully. In order to find the value of B, obviously you need period. You have the period. So note down this formula as well for the period as I wrote earlier in my explanation. So period's rule is 360 divide B. So let's put 14.4 equals to 360 divide B, and I can find the value of B, and that will give me, let's go, 360 divide 14.4. Oh, I'm getting a very nice value, 25. So that is the value of B, okay? So if I have the value of B, I can write my final sinusoidal model as h of t equals to, okay, so it's A, which is a 0.76 sine 25t and plus a point 0.5. So that is my answer. Now I'm running out of space, so we can do the rest of the parts on the next slide. Part E. Find the value of the function at 230. So for 230, we just need to substitute a 2.5 into the function. So this will give me, let's calculate the value, 0.76 sine 25 times the 2.5 and plus a zero point 0.5. And make sure your calculator is in degrees since it's the SL question. But in the HL exam, you can get radian measures as well. So HL students need to change their calculators to radians. Okay, so I'm getting, let's just copy this down. It's a big answer. Okay, so I'm getting, let's just write it. It's 1.17, yeah, three significant answer. Give your inexact answer, and then in the end, you can give the actual answer, right? Okay, so now they're saying, state the meaning of height is less than 0 in this case. So we can check these are the region where the height is less than 0, these points, right? So you can clearly see that you can say the road is fine for the cars, or you can say that the road is above the water level, right? So let's write this. Road is above the water level. So it's good for the cars to travel. Okay, part G. Find the length of time on Tuesday when height is less than 0. So now we need these times where your function is below the x-axis. Okay, so you need to find this time interval, and you'll add them, and that will give you the length of time. Okay, let's get this. For this, we need to graph the function. So you will go to the graphing part. Okay, let's just note this down. 0.76 sine 25. In place of t, I can put x and plus a 0.5. So let's see, what do we get? Oh, I need to set my v window. So let's make it 0 to, let's say 25. Okay. And let's make it -3 to 3. Okay. So to be on safer side, I just made it 3. I could have made it like 2 to -2. It doesn't matter. Let's sketch it now. Okay, fine. So it's the exact function which is given in the question. Go to GSolve and get the roots of this equation. So there are some roots. I need these root values. This one, let's put it over here. And let's see this one. I need this one as well. Okay, right. So here we go. That is another one. Okay. And don't forget this part as well, right? So 23 point something something. This is also the time when height is below 0, right? Let's oh, note. All right. So the last time is going to be x equals to 24, right? So let's go to the normal part of the calculator, and first thing I need to do is 12.7544 1958. I need to be careful. Take unrounded answer. If you round them prematurely, you will get some slightly a different answer, which is not correct. So always use like these bigger numbers, and in the end you can write your answers as rounded three significant figure, right? Okay, so 8.845580417. Okay. Let me just check. Have I written it correctly? 845580417. Right. Okay. So add another length of time, which is a 24 minus 23.245580 and 42. Okay. So I've faded my numbers. Let's go. So I'm getting the final answer as this thing. So let's get that answer. And that is for part E. You can give the final answer as 4.66, right? Hours. So that's it. So this one is from November 24, HL paper 1 and time zone 0. It says the amount of daylight L in hours in London in 2024 can be modeled by this function. So you can see this time there is A, B, there is a phase shift, C, and the midline, D. Okay, so that's the extra feature of the HL question, where A, B, C, D are positive and T is the day of the year. For example, day 1 is 1st January, day 2 is 2nd January, and so on. So now they're saying the maximum value of L is 16.63. I can see that. The coordinate is given. Hours on day 173. That is 21st June 2024. So you got to be careful with this information, right? So this happens on 21st June, right? Okay. The minimum value of L is 7.83 hours on the day 356. So this is day 173. Day. This is day 356. And this is 21st December, right? Okay. The information is shown in the following table. Let's move on to the parts. So let's solve the parts. Find the value of part A, D. So I need to find the value of D. Let's quickly use the same idea as earlier. Take the maximum value, add the minimum value, and half it, right? So let's go find that out. 16.63 plus 7.83. Okay. So if you divide it by 2, I'm getting 12.23. So 12.23, or you can give the three significant answer as 12.2, right? But if you want to use D value, you should use the unrounded one. Okay. Part B, part A. Okay, I need to find the value of the amplitude. For amplitude, I either, as I used earlier, you can make the midline and then find the difference, or this is a good way, like just subtract, like what? Max minus min and half it. So this will straight away give you the value of A. So 16.63, subtract 7.83 and divide it by 2. So I'm getting a 4.4 for A value. Okay, that's D. This is A. Now I need to find the value of B. B can have two potential values since this is the HL exam. So if you use the 2 pi divide B version, which is a radian way of finding the period, or 360 divide B, you will get different B values. But remember, since your calculator will be in radians, so your C value is going to be the same for both, right? So since the question doesn't specify, I can maybe use the same degree values, right? Okay. So let's go. I need the period first. How do you get the period? So I know that half of the period is given. So I just find this difference and double it. So let's get the period first. How do you get the period? It's going to be 356, subtract 173, and double it, right? So let's go. This is going to be 356, subtract 173, and divide, sorry, my bad, and double it. Okay, so that's 366. So if I put this value, that's why I was saying, like, if you put 360 divide B equals to 366, you will get a different B value, and you can get a different B value for if you use 2 pi. You can check the mark scheme. If the question doesn't specify, then I believe both values should be given over there. Okay. So let's do 360 divide the answer. Now I'm getting this big value for B. Okay. So let's put it over here. This value. Okay. But you need the final answer as three significant figures. So 0.984, right? Okay. There we go. And part D. Now I need the C value. There are some tricks you can use here, but the best, I think, which is error-free, is just use your sinusoidal function. You have your A value, B value, D value. You can substitute one of the given coordinates. Like, let's say if I substitute 16.63, and that will be equal to 4.4, and sine of B, which is going to be 0.98361. Let's take this much. T minus C and plus I need the D values, which is so that I'm using 12.23. Okay. So I need to do these calculations. So let's do these calculations in the next slide. So now we need calculate this. So 16.63 and subtract a 12.23 and divide it by a 4.4. Do the sine inverse. I'm just doing the reverse operations. Okay, let's just get this thing first. And this is 0.98361. Oh, I didn't put the t value. It was 173 for this one, right? And minus c. So let's get this first. So I'm going to do shift sine inverse of this whole thing, right? So let's put a bracket 16.63. The newer versions have the fraction thing as well, but this one doesn't have them. I'm using the older version right now. 4.4. Okay, so let's get this. It's 90. Divide by 0.98361. Okay. So I'm getting 91.49968. 91.49968 equals to 173 minus C. So C is going to be 173 minus the answer. So I can just use 173 minus the answer. So I'm getting 81.50032, 81.50032. So C is going to be 81.5, right? And that's it. And in the end, I would like you to note down carefully each of the important things from the lesson that was given today. Amplitude, midline, period, general sinusoidal model, and what does each of these terms mean? Keep following for more useful resources. Over and out.